Hello everyone, my name is Wayoud Bouzeraib. I am a PhD student in the University of Constantine II. Today I am sincerely honored to present to you my contribution to ICAASE conference. It consists on proposing a blockchain data balance using a generative adversarial network approach application to smart house intrusion detection system. This work was developed in the laboratory of the Constantine II University. As a plan to this show, we first highlight the context and the problematic of our work. Then we precise our main objective. Afterward, we present some relevant related work and their limits. We describe the principle of our contribution. Finally, we conclude our presentation with some perspective. So we begin with the context of our subject. Nowadays, a growing number of people are connected to the internet in one way or another 24 hours a day. How many of you could actually make it through the day without your smartphone? In fact, an ever-increasing number of people have and really own 3, 4 or more smart devices. This means including smartphone, exercise, health monitor, e-reader, and tablets. Today in our world, there are more smart devices than there are people. As shown in the slide, in 2020, each customer will have an average of 6.58 smart devices. In this year, 13 billion devices are connected, and they will be 41 billion by 2027. Consequently, the world is quickly being covered with networks that allow digital devices to interconnect and transmit. Think of the much of the network like a digital skin surrounding the planet. With this digital skin, mobile devices, electronic sensors, electronic measurement devices, medical devices, and gauges are all able to connect. They monitor, communicate, evaluate, and in some cases automatically adjust the data that's being collected and transmitted. As a society embraces this digital device, as a digital network continue to grow around the world, and as the economy benefits of digitalization continue to grow, we are seeing the digital transformation. This digital transformation is the application of digital technology to provide the stage of business and industry to innovate. This digital innovation is now being applied to every aspect of a human society. The development of Internet of Things was the result of a number of previous developments, from the advent of the Internet to the sensor and Wi-Fi networks. In simple words, IoT is a system of interrelated computing devices. The most important characteristics are unique identifiers and the ability to transfer data over network. IoT devices have many characteristics like heterogeneity, communication technology, and scalability, but in this presentation we will focus on security and intelligence. IoT starts as a niche market for hobbyists and has evolved into a huge industry, but with this growth came security vulnerability. Manufacturers, retailers, and the big business are all finding ways to leverage IoT platforms, combining the data that they collected with analytics, and advanced reporting systems. In the aim to ensure the security of IoT devices, we need to make sure of 4 points: confidentiality, availability, integrity, and no repudiation. And there are many solutions to apply to those points. One of those solutions is blockchain technology. Blockchain is a linked list data structure in the form of a chain, where each node in a linked list is named as a block, containing, for instance, transaction data record, detection data records, and network control messages. Each particular block in the blockchain has a cryptography hash data structure containing the information of the previous block, the timestamp, and transaction data. In other words, the hash data structure indicates a pointer to the previous block stored in the blockchain. In this case, the blocks in the blockchain are arranged in the time. In IoT systems compatible with blockchain, multiple copies of the blockchain are synchronized and stored in distribution manner. In all or some of the systems, IoT participants, a blockchain network refers to a connected system where all participants maintain a chain of blocks, which may be public or private. This solution assures the integrity and availability of the data. There are many ways to detect intrusion in datasets stored in the blockchain. The most famous systems for this objective is Intrusion Detection System (IDS) and Intrusion Prevention System (IBS). IDS simply is a device whose task is to discover the attack process on the network and send alerts to the network administrator. But EBS is a device that doesn't the same job as EDS, which is able to take action directly from letting the packet pass forward or drop. In the last few years, EDS was the most used because it doesn't disrupt the data traffic. EDS have two types of detection: signature-based EDS and anomaly-based EDS. In the beginning, they depended on signature-based EDS, but it was so limited because it can detect every intrusion, especially the new one. But in the last few years, anomaly-based EDS show a positive result because it depends on abnormal behavior on the network. In this context, we go forward the next point of our presentation and we focus on the problematic. Most of EDS systems that rely on AI need balanced training dataset, but in reality, the data is usually unbalanced. There are many ways to solve this kind of problems. We mentioned some of those solutions like collecting more data, changing performance metric, resampling dataset, generate syntactic samples, try different algorithms, different models, and try different perspectives. The most used solution is resampling dataset, which may be used in two ways: undersampling and oversampling, where undersampling depends on reducing the majority to precede the equivalence of the minority, and the opposite for the oversampling. The undersampling technique can be lead to lose the important information, but that may not be the case with oversampling technique. In the face of this problem, we set the following objective. This objective is to use imbalanced generative adversarial network (IGAN) and conditional generative adversarial network (CGAN) to generate representative samples for minority classes and multi-classes, countering the classes imbalance problem in intrusion detection. The example in the figure clarifies that if we have 2000 samples of minority classes and 98,000 samples of majority classes, and our model goal generates samples for the minority classes to balance the dataset. Before describing our approach, it is necessary to situate our work with others in this field. This table summarizes some relevant recent work dealing with GAN and blockchain. Through the table, we note that applying EDS to the IoT associated with the blockchain is considered in only a few very recent work, as in the work of Francisco and Mohammed Farghli. Moreover, we observe that GAN have not been applied to the blockchain yet. In our approach, we aim to consider GAN in a blockchain framework. Now let us explain the main principle of the proposed approach. Our contribution is based on approach of GAN. The approach contains two models, generator and discriminator. Generator tries to deceive the discriminator, and the discriminator tries to distinguish the fake samples from the real one. This operation runs in iteration where each part of the operation gives a feedback to another part. In the end, the generator will be able to generate fake samples that look much like the real one. From the last slide, we conclude that the generative adversarial network is a min-max game, where the generator and discriminator has two contradictory roles. In this figure, we propose a generative adversarial network models, which contain two main submodels: conditional GAN built to mapping from observed input X and a random noise vector Z to the output Y. The generator G is trained to produce output that cannot be distinguished from the real input by adversarial training discriminator D, which is trained to do as well as possible to detect generator fake samples. The advantage of this submodel is allow us to choose the type of output through the appropriate selection of the inputs. At the end of this phase, we calculate the lower present label model, and then we will have the information of presence rate of each class. After that, we will generate the number of samples to balance the dataset. Again, contain three components: imbalanced data filter, generator G, and discriminator D. The imbalanced data filter samples from the minority classes and calculates the generator quantity. After that, G and D conduct the adversarial learning. At the end of this model, we get a balanced dataset, in which each classes we will have the similar number of samples. We conclude our presentation with two things: a summary of our paper and perspectives of our future work. To assure the security of IoT devices, we use blockchain characteristics which give us a trust in IoT data and flexibility to the distribution of the blockchain. Otherwise, the use of game guarantee the generation of required data. In this work, we propose a generative model to balance data for intrusion detection using blockchain data logs. The contribution can be summarized in 2 points. We define conditional GAN to generate data noise on blockchain logs, and we define unbalanced GAN to generate data on minority classes. In future, we will focus on 2 directions. The first one deals with automatically feature extraction to improve the model, and the second one is define models that improve the detection of attacks before they happen based on network behavior. I finish my presentation. Thank you for your attention.